Variation and adaptation are two of the big principles that explain how plants and animals change over time. Variation and adaptation are all around us every day, in nature, in our pets and domestic animals, and even in the food we eat. Let's look at variation first. When animals and plants reproduce, they don't make exact copies of each other. Imagine a litter of puppies from two parent dogs. No two puppies out of the litter are exactly alike. They may have differences in fur color, size, or even other differences we can't see. In fact, every puppy may be different from every other puppy in many small ways. This happens because each puppy gets a slightly different combination of genes from the father and mother. The random mixing of genes is a cause of variation. Variations are passed on to offspring from their parents. That's an important part of the story. No matter who this puppy mates with when she grows up, her puppies will very likely be all white, or at least have some white fur. Fur color is determined by genes. Variations in fur color are therefore passed on from one generation to the next. Our second big idea is adaptation. Some variations make a plant or animal more successful. By successful, I mean able to reproduce and pass on their genes to the next generation. For example, suppose an animal had to hunt for its food in the Arctic, where it's cold, white, and snowy most of the year. Long white fur would be a good thing to have. The polar bear and the Arctic fox are both winter hunters, and both have these characteristics. White fur is a good adaptation for a predator in a snowy climate because it helps the animal sneak up on its food or hide from its predators and survive. Here's an example of a helpful adaptation. A pepper moth has two main color variations. Most moths are gray with dark spots. A few moths are brown, almost black. These moths live in fields where they often rest on tree trunks. In fact, the gray moth has a color pattern that is very hard to see against the tree trunk. This protective coloration helps the moth hide from birds who like to eat moths. There's a good reason that the dark-colored moths are rare. Watch what happens when a flock of birds decides to stop for a snack. What did you learn from watching the birds? A. Birds ate equal numbers of black and gray moths. B. Birds preferred gray moths. C. Birds preferred black moths. Or D. Birds ate all the moths regardless of color. Good observation. The birds ate 4 out of 5 black moths. What do you suppose is the reason for the birds eating the black moths? If you thought that their color made them easy to see, then you are in agreement with the scientists who observed something interesting happen to these moths. The black variation of the pepper moth was once quite rare because it made the moths easy targets for birds. The gray color was a much better adaptation for surviving on a gray tree trunk, like most of the trees where these moths lived. Most of the moths who survived long enough